Question 3, Part B. A layer of plastic cuts out 15% of the light and lets through the remaining 85%. Part 1. Show that 2 layers of the plastic let through 72.25% of the light. One layer of plastic lets through 85% of the light. If we add another layer of plastic on top of the first layer of plastic, it lets through 85% of the light that was let through by the first layer of plastic. In other words, 85% of 85%, or 85% times 85%. And as a decimal, that can be represented as 0.85 to the power of 2, or 0.85 times 0.85. And that evaluates to 0.7225, which equals 72.25%. Therefore, 2 layers of plastic lets through 72.25% of the light as required. Part 2. How many layers of the plastic are required to cut out at least 90% of the light? Blocking 90% of the light by the law of complements implies letting through 10% of the light. So we can solve for n the equation 0.85 to the power of n equals 0.1, where n represents the number of layers of plastic. Because we're trying to solve for an unknown index or an unknown power, we can take the log base 10 of both sides of the equation and then isolate n by applying an appropriate logarithm law. So taking the log base 10 of both sides of the equation, we get log base 10 of 0.85 to the power of n equals log base 10 of 0.1. Applying the power law of logarithms, the n comes out to the front, so we get n times log base 10 of 0.85 equals log base 10 of 0.1. Now we can isolate n by dividing log base 10 of 0.1 by log base 10 of 0.85. So we have n equals log base 10 of 0.1 divided by log base 10 of 0.85, which evaluates to 14.168, and so on. Now it's important to note that if we round this value down to 14 layers of plastic will block less than 90% of the light, and it's clearly stated in the question that we want the number of layers of plastic that will block at least 90% of the light. So we need to round this value, 14.168, up to the nearest integer, which is 15. Therefore, 15 layers of plastic are needed to block at least 90% of the light.